Mr. P, which one's a real Claude?
I'm not sure, but we've got to start the show. Utsi, can you tell which one it is? We've got to get started on Unlocking Science. Welcome to Unlocking Science. Our goal is to glorify God by studying and unlocking the secrets of His amazing creation. I'm your host, Mr. P, and I'm joined again by Professor Danny Faulkner, and we're going to be talking about some things that might make your brain hurt a little bit. And we've got something on the table right down here that's going to be kind of the Kickstarter to start thinking about these things. So if you look at the stirring rod that you see here in this beaker in front of us, you might see something different depending on the angle that you're looking at it. What are the people out in front of us looking through the cameras probably seeing there in the beaker?
Well, we know the stirring rod's actually straight, but most people are going to see it bent when it hits the water, and that's due to refraction of light in the water itself.
Mm-hmm. And we can prove that. If we pull the stirring rod out, it is indeed very straight. But when we put it back down in the water, it appears to bend as that light is being bent as it works through there. And that's why we have titled today's episode, Seeing Isn't Believing, because we're going to examine how our brains can be tricked sometimes as we look at all of those different things in the world around us. We're going to be exploring what we typically call optical illusions. So what's going on in the beaker right here with the rod really isn't an optical illusion though, is it?
No, it isn't. Usually we think of an optical illusion as being a trick that our eyes and our brains play upon us, seeing things as they really aren't. In this case, you're really seeing as it is because the light is refracted. So it's a very real effect, even though it doesn't correctly tell us what the shape of the rod is.
So there's a bit of trickery going on here. Yeah. And we often think of people on stages, we call them magicians. They do tricks and illusions that kind of deceive us. They use distractions and sleight of hand to make things happen. So there's a difference between sleight of hand and optical illusions and some of those things, and we're going to explore that a little bit.
Well, Mr. P, how do our eyes see?
Well, it's a really complex process, and I bet you're a physicist, so you know a little bit of the beginning parts, but let's take this model of the eye. We'll move our beaker over here to the side a little bit, and let's take a look here and see some of the different parts of our eye that God's created that's going to allow us to be able to see. So when we think about light, you know light is part of the electromagnetic radiation. So that means it can move through space, and light waves have different forms of energy. So which light wave, the purples or the reds, have more energy in them?
The purples do.
Okay, so purple wavelengths, we think about, you've met that guy before, Roy G. Biv.
Yes, I have met Roy G. Biv many times.
Roy G. Biv helps us remember the names of the colors inside of the color spectrum. So reds have lower energy, violets have more energy, and those light waves come into our eye and they pass through the front of our eye. So we have a structure out here called the cornea, and then that passes through that opening in your eye. You think about the colored part of your eye. Some of you may have gray eyes or blue eyes or green eyes or brown eyes. That iris is a little muscle that opens and closes, and that's kind of like a camera lens that controls how much light comes in and out, the diaphragm there. And then it goes through the lens structure of your eye and it hits the back. And that back part's called the retina. And there we have special chemical receptors that are called rods and cones. Okay, the rods help us detect light and dark, and then the cones help you see color. You know how I always remembered that? The alliteration. Yeah. Because cones help you see color. So we've got 3 different cones back there, red, green, and blue. So if we have 3 different cones, that means we have trichromatic vision, and we can detect all of those. So we get the energy from those stimulates those cells, and then that sends an electrical signal that goes through your optic nerve, which you can see passing through the back part of the eye here, and that optic nerve connects back to your brain, and all of that gets interpreted inside of your brain. Now, the brain would have to be a little bit bigger than this for this model. That's a pretty big eyeball. Yeah, it'd be a really big brain back there. But all of those things then go into your brain, and that's the process of how we see. So it's a pretty complicated system that God's designed inside of our bodies. Okay. Now, do you have perfect vision, or do you have to wear corrective lenses to be able to see?
My vision is very good as long as I'm looking at something more than 30 inches. Used to, I could hold things up really close, but at my age, I need reading glasses for
I
up
keep
close.
those handy too.
But
Yep.
beyond 30 inches, I can see extremely well, which being an astronomer, I'm very thankful.
And when you had your eyes checked, you probably went to the eye doctor and they did some eye tests to see how your eyes were working. I did that recently, had to go through that process. I wear contacts most of the time. So let's give everybody at home a little eye test and see how their eyes are working, okay? I've got a couple of examples here that we're gonna use to see how your eyes are working, okay? I've got two different shapes here. So everybody focus on these shapes for a second. We've got the green and the purple. I want you to think about these two shapes. I want you to tell me which one do you think appears bigger? The purple one or the green one? Yeah, now you've been to the eye doctor before, they're always doing that. Number one better, is number two better? Number one or number two? We're going back and forth. So green or purple? And which one do you think now?
You're allowed to change your vote.
Did something just change? Did that just change your mind? Did you think the purple one was bigger a minute ago and now the green one's bigger? Well, what about now? Now which one do you think is bigger? What about now? Okay, now something has changed and there's something going on that doesn't quite make sense to your brain as I hold all these things in different positions. Now let's do something totally different and put them up in this configuration. Now what do you see happening? Ah, there's a big change now. Now you'd probably say they look the same size. So there's something happening that's tricking our brain. This is truly an optical illusion. So as your brain looks at this, the green has the long edge next to it, and the purple has the short edge next to the long edge of the green. So what is your brain thinking?
Your brain's thinking the green one's longer.
Because it's got to be bigger because the green edge is longer.
It's comparing it to something next to it.
Until we put the long edge of the purple one next to the short edge of the green one, and duh, the purple one's obviously bigger. Until the long edge of the green one's next to the purple one, and duh, the green one's obviously bigger. So this is a way that our brain is tricked. But if we put them next to each other where we're comparing the same sides, it's obvious that the size, and indeed, they are exactly the same size. So our brains can be deceived. So your eyes don't work as well as you think that they do. So things aren't always as they appear, right?
You're getting now to thing we call perception, how we perceive things.
Yeah, and that is actually our big science word of the day. So perception is the way that our brain takes all of those signals from all of our senses. Now, we usually think about 5 senses, but we've got a lot more than 5 senses. We experience things in lots of ways in our body. So we usually think of sight and smell and taste and touch and sound, but we've got other senses that we experience, and our brain interprets all those signals, and that's how we perceive those things. So you were perceiving those colors, and did their perception match reality?
They did not.
They did not. And that's the problem. We have to be aware of those things and understand how our brains can actually be deceived by those types of things.